Welcome to Daniel's Extra Chemistry Help classes. Desh. I'm Daniel. Full name is Alexander Daniel. I have been working with the chemistry students at different levels in India and also in community colleges in the US. I know this time of COVID-19 pandemic is very difficult for the students. These classes will give extra help to general chemistry students of all streams, but is mostly based on the 11th standard CBSE syllabus in India. These classes will give you tips to make concepts easy, and also I will help work out numerical problems which will help you in the tests and also in the entrance exams. Okay, let's go to the subject now. Chemistry mostly deals with substances around us, and we study the properties and the interactions between the substances. General chemistry topics are almost the same for different courses. They may differ in the extent and the order in which they are presented. Desh goes with the CBSE curriculum just as I have told you, and I will be trying to help students with easier ways of looking at concepts, and also we will work out numerical problems. Okay, chemistry studies about the substances around us, which we call as matter. Now, matter can exist in different physical states like solid, liquid, or gas, and also depending upon the particles present in the substances, we can have elements, compounds, or mixtures. Now, element contains only one type of atoms, while if two or more different types of atoms combine together, we get a compound. But what we see around us is a mixture of all these substances together. Yeah, that we can have elements, compounds, and all these substances combined together. For example, the air which we are around us contains nitrogen, oxygen, carbon dioxide, water vapor, so many things together. And the seawater contains, in addition to water, we have different types of salts all mixed together. So that's the normal thing in nature. Okay, now when we study the properties of substances, we want to measure. Okay, and the measurement usually has two parts. One is it has a numerical value, and the other is a unit. So in this case, the 6.8 is a numerical value, and the meter is the unit. Okay, now we use different types of systems, unit for the units. But scientific community usually uses a modified form of the metric system, which we call as the International System of Units, or the SI system. Okay, and the SI system, we have actually 7 base units, which you have to remember. They are the mass. For mass, we use the kilogram. For length, we use the meter. For time, we use the seconds. For temperature, we use Kelvin. The amount of substance, we use mole. Light intensity, we use candela. And the electric current strength is ampere. And in this base units, mostly the light intensity candela and the electric current strength ampere is mostly used in physics. But the other ones are the units we had to be careful about. And out of this, you have to be careful about the unit of mass, which is kilogram, but usually students think it is the gram. And also the temperature unit, usually students think as the degree Celsius, but it is the Kelvin. So just remember this. We'll be studying more about the units while we are actually discussing. Okay. Now, in addition to the base unit, you have to take care of the prefix multipliers, which is a very important thing in SI systems, where we can actually go to higher units and lower units based upon the prefix multipliers. Okay, now The prefix multiplex, in my time when I was actually studying at the lower, in the nursery classes, we had only a few of the prefix multipliers like the milli, centi, deci, meter, or the basic unit, and then we have deca, hecto, kilo in the higher unit. And in that case, we actually learned this prefix multipliers even in the nursery by using rhymes, just like two group of students will be standing facing each other, and one student group will be just saying milli, centi, deci by advancing, while the other group will be going back and back, and then the next batch will say deca, hecto, kilo, and this batch will be moving back and will be just going on rhyming this milli, centi, deci, meter, deca, hecto, kilometer. Very easily we actually learned that even in the nursery classes. But nowadays the unit have actually increased and decreased to a large extent. For example, in the lower part we have, in addition to the milli, which is 10 to the power of -3, we have -6 is micro, -9 is nano, -12 is pico, and -15 is femto. And on the higher part, in addition to the kilo, which is 10 to the power of 3, we have the mega, 10 to the power of 6, giga, which is to the 9 to the power of 9, tera, which is to the power of 12, and peta to the power of 15. Okay, now these prefix multipliers you have to remember. Two things you have to be careful about. One is the letter representation, and second is the numerical value connected with the letter representation. Okay, when I say about the letters, you have to remember most of them contain only one letter, while the deca has two, because deci is already having a D as the representation. Now again, the milli is M, so for micro you cannot give M, so we use a Greek letter mu. And in the higher part, when you come to the mega, giga, and tera, and peta, if you have noticed, you see them as capital letters, M, G, T, and P, and you have to be very careful that you have to use the capital. Otherwise, if you say millimeter, we use the small m and the m, while if we, instead of using the small m, if you use the capital M and the meter, then it becomes megameter. So you have to be careful about the prefix multipliers. Okay, now in addition to the base units, we also have, and the prefix multipliers, we also have some derived units. For example, if we're using an area of if a particular space, we have to multiply the length and the width. That means you are multiplying the meter to meter, so meter square is going to be your SI unit for that. Similarly, if you're using units for multiplying in the volume case, you have length, width, and height. 3 meters multiply will give you m cube, but m cube is a very large unit of volume. So in the lab, usually we use the decimeter cube and the centimeter cube, which are smaller units, which are the usual things we use. So since this is very convenient, the decimeter cube is very convenient, we represent it by a single unit which we call as liter. So the decimeter cube is a liter, and so 1 meter cube is connected to the liter by 1 meter cube is 1,000 liters. And if you just connect the meter cube to the milliliter, remember every liter has got 1,000 milliliters. So if you just connect the meter cube to the milliliter, it becomes 10 to the power of 6 milliliter. And if you just think about all the connections, we know a milliliter is exactly equal to a 1 centimeter cube. Okay, so these are some of the things you have to be careful about in the volume case. Now, another thing we usually measure in the lab is the density, which is mass divided by volume. For the mass, the base unit is kilogram, And for the volume, the SI unit is meter cube. So kilogram over meter cube is going to be your SI unit. But conveniently, we use in the lab gram per centimeter cube, or instead of centimeter cube, we can also use milliliter. Usually in the case of liquids, we use the milliliter. So gram per milliliter is going to be your unit for the density. That's the convenient form of that. Now, in addition, the temperature is a very important thing which all the sciences are actually using. And for the temperature, we have different systems actually, very popular things. For example, the US is using the Fahrenheit, and usual temperature measurement is using Celsius scales. So you have to connect the Celsius and the Fahrenheit to the Kelvin, which is the SI unit. So the conversion between them is very important for the sciences. So let's think about how we can convert between the different temperature scales. Two things you have to be you have to remember about this is, just think about the different scales by using the three thermometers actually placed side by side. Now, when you calibrate a thermometer, you're using importantly two points. One is the freezing point of water. For that, you can place the thermometer in water and ice mixture, and you can mark the point, which is the ice point. And then you place the thermometer in boiling water, or say in the steam and boiling water together. Just place it there and mark the point, which is the temperature of the boiling water. So these 2 points are the graduations which we usually use for calibration. Now, for the 3 scales which we already mentioned, like the Celsius degree, the Fahrenheit degree, and the Kelvin degree, they are actually having different numbers or different and actually units for the 2 points. For the Celsius degree, the ice point is 0 degrees Celsius, and the boiling point of water is 100 degrees Celsius, and in between we have 100 Celsius units. While if you think about the Kelvin scale, the ice point is 273, and actually there is a small fraction, decimal fraction 0.15, but we usually don't use it for convenience. So 273 Kelvin is the ice point, and the boiling water temperature 373, and in between we have 100 degrees. So basically the size of the Celsius scale and the Celsius unit and the Kelvin unit are the same, because if you look at the 2 thermometers or 2 graduations, we know that. But for the Fahrenheit scale, the ice point is 32 degrees Fahrenheit, and the boiling point of water is 212 degrees Fahrenheit, and in between we have 180 divisions or 180 Fahrenheit units. So what does that mean? It means that in the place of 100 degrees Celsius divisions, we have 180 Fahrenheit divisions. Or in other words, you can say 10 Celsius divisions is equal to 18 Fahrenheit divisions. Or if you want to make it more simple, you can say 5 degrees Celsius division, or 5 degrees Celsius divisions is equal to 9 Fahrenheit divisions. We can use that ratio as a conversion thing. Or you can say for every 1 degree Celsius we have 1.8 degrees on the Fahrenheit scale. So these things, if you keep in mind, we can easily convert these things together. So if, from Celsius to Kelvin, okay, and Fahrenheit to Celsius to Kelvin. So these are the 2 roots usually we use. Okay, so these 2 things you have to remember is the degree units in Kelvin and Celsius are the same, the size, while a degree Celsius is equal to 1.8 degree units in the Fahrenheit scale. Second thing is the common ice point for degree Celsius is 0, for Kelvin is 273, and for the ice point for the Fahrenheit is 32 degree. Okay, now if you want to go from Kelvin to Celsius or Celsius to Kelvin, it's pretty easy. We know that the Kelvin is always 273 more than the Celsius scale. So if you want to go from the Celsius to Kelvin, just add the 273. Okay, and if you want to go from the Kelvin to Celsius, you take away or minus the 273 from the Kelvin scale, you going to get the Celsius. So that is pretty easy. You only have to, do that addition or subtraction of the 273 to go from the Celsius to Kelvin or, Kelvin to Celsius. Okay, now Fahrenheit to Celsius is a little different. We have two things you have to do. One is the ice point correction, and the second is the scale. The number of units on the two scales are different. So that way you have to have one more correction. For example, suppose we want to go from Fahrenheit to Celsius. Okay, remember the Fahrenheit starts from 32. So take away the 32 from the Fahrenheit. You get Fahrenheit divisions. And remember, Fahrenheit divisions are more, so divide that with the 1.8 to convert those divisions into the Celsius. And Celsius does not have any the ice point correction starts from 0, so just keep it like that. So Fahrenheit minus 32 divided with 1.8 is going to convert the Fahrenheit into Celsius. And if you want to change the Celsius to Fahrenheit, now Celsius, there is no ice point correction there, so you can directly multiply the Celsius divisions with 1.8, which will convert it into Fahrenheit divisions. But the Fahrenheit starts from 32 for the ice point, so just add 32. So if you want to go from Celsius to Fahrenheit, multiply the Celsius with 1.8, then add the 32, which is the ice point correction. So let's think about one or two problems, based upon this idea. The usual thermostat settings for AC rooms in the US is 72 degree Fahrenheit. What is the equivalent on the Celsius scale? A common question you can actually expect. Now, if you want to go from Fahrenheit to Celsius, what are the things you have to remember? Fahrenheit is basically, starts from 32 as ice point. So you have to take the 32, that is minus 32. And then whatever you get, you divide with 1.8 to change the Fahrenheit divisions to Celsius. And then Celsius does not have any, ice point correction. So you can keep that temperature. That basically 72 minus 32 divided by 1.8 gives you 22.2 degrees Celsius. Now, the summer temperature in New Delhi can go up to 41 degrees Celsius. What is this temperature on the Fahrenheit scale? Okay, now, again, we are given the Celsius. We have to go to the Fahrenheit. And remember, Celsius does not have any, ice point correction. So we can start with the 41. Change it into the Fahrenheit divisions by multiplying with the 1.8. And then you apply the ice point correction for the Fahrenheit, that is you add the 32. So just multiply with 1.8 and then add 32. So that's what we have done. 41 times 1.8, add 32, that gives you 105.8. So if you know this, you can easily do this, which is a common, problem you can get. The normal body temperature is 98.6 degree Fahrenheit. Convert this into degrees Celsius. How will you do that? Okay, you already know the idea. The Fahrenheit, has got that ice point correction 32, so you have to take away the 32 from 98.6, and then whatever you get as the divisions, you have to change it into Celsius degrees. Means what? The number will reduce. That means you divide with the 1.8. So it goes like this: 98.6 minus 32 divided with 1.8. That gives you a 37 degrees Celsius. So I think you actually got the idea. Can easily go from the different degrees, and always remember the Kelvin is going to be the SI unit. So you can easily convert the Celsius to Kelvin, but if you want to go to the Celsius from the Fahrenheit, you have to do the changes there. Okay, now when we measure, we actually are dealing with sometimes high numbers, very large numbers, and also very small numbers. Now by using a particular form of the scientific notation, we can make it easy. That way it will be easier to just look at the number, you get the value of the number. So what is that particular way of representation? Any number can be represented in n times 10 to the power of n, where n is a number in between a 1.00, 9.999. If you look at that, you have a one whole number part and then decimal numbers there. And the small n is integer values, where it may be a negative value or a positive value depending upon the number you are representing. So n is an exponent. The small n is an exponent having positive and negative values, and that capital N, that is the first number, is going to be a number in between 1.000 9.999. So that's the way any number is represented. Let's take a typical example. So if you go to 238.508, that is not the scientific form. So in the scientific form, we only have one whole number and the rest is going to be decimal numbers. So you want to change the decimal point to 2 positions to the left. So if you just change that, the number reduces, and that should be balanced by a 10 to the power of 2 to keep the value of the number. So you change the decimal point 2 places to the left, and the number can be written as 2.32508 times 10 to the power of 2, which is the correct representation of that number in the exponential form, or say the scientific form. Okay, another number, 0.00016. How will you write it in the scientific form? Remember, this number, as you look at it, you know that it's a very small number. And the standard form should have what? One whole number, and the rest is going to be your decimal fractions. So if you just want to change the decimal place from this point to the 1, it's going to be 1, 2, 3, 4 places you move to the right. And when you move to the right, you have to balance that change of the size or the value by a minus exponent. So 4 places you move to the right, which which comes as a negative 4 as an exponent. So the number is going to be 1.6 times 10 to the power negative 4. Okay, so suppose we have a problem like that, which contains so the question is like this: convert the following into base units. So what do you have to remember? You have to remember the base units in the different things, like in the picometer, meter is going to be your base unit. In microseconds, seconds is going to be your base unit. In the gram, which is the weight, instead of the milligram, your kilogram is going to be your base unit. So that's the first thing you must remember. Second thing is how to replace the prefix multipliers with the correct number, and conveniently change it into the standard base unit thing. So let's think about remember the base unit you already studied and the prefix multipliers you actually have. So you already have the idea about the base unit. We already have only 5 of the base units, and which you have to remember. And then we have the prefix multipliers, the normal ones, and the lower ones, and the higher ones. I think you remember that. So suppose we want to, so the strategy is this: the basic units in this case is the meter, the seconds, and the kilogram base unit. And then the prefix multipliers has to be changed into the normal form. So let's take the first one. So the base units are you know kilogram, meter, seconds, ampere, Kelvin, and the mole. These are things you already know. That's a system thing. So if you think about the 28 point, let's take the first one, 28.7 picometer, what do you have to do? The pico we know from the prefix multiplier, we know is 10 to the power negative 12. So we just replace the letter representation with a number representation. So we replace the pico with a corresponding number, which is 10 to the power negative 12, and then we had to change it in the standard form, that is a scientific notation. So here you have to change the decimal point to the 2, which is 2.87, and the 10 which comes out of that number has to be combined with a minus 12, which actually 10 to the power of 1 and 10 to the power of negative 12 will give you 10 to the power of negative 11. So that's going to be your number corresponding to the 28.7 picometer. Okay, let's go to the 15.15 microseconds. Now micro, the corresponding number is 10 to the power of negative 6. And then again, converting it in the standard form, the 15, you're going to say 1.515, and the 10 to the power of 1, which comes from here, you combine it with the 10 to the power of negative 6, giving 10 to the power of negative 5 seconds. And finally, the milligram thing. Substitute the milli with the corresponding number, which is 10 to the power of negative 3. Now, we have to have a kilogram here. So you have to be very careful about how we actually do this. So I'm going to do what? This number which you have here, I'm just going to convert into standard form. So the 25,365 is just change it into 2.5365 and take the 10 to the power of 4, which comes out of that conversion. And then already we have 10 to the power of negative 3 from the milli. Now, what do you want? We want the kilo. Now, what is a kilo? Kilo is 10 to the power of 3. So just separate the 10 to the power of 3 from this, which will give you 10 to the power of 1 remaining there. That the 10 to the power of 1 you combine with 10 to the power of negative 3, which gives you 10 to the power of negative 2. And in the place of 10 to the power of 3, use the letter representation, which is k. So basically the number comes up 2.5365 times 10 to the power of negative 2 kilogram as the thing. So this actually makes gives you an idea about how we use the prefix multipliers and how we can actually use it conveniently in these conversions. Okay, now I think you have some idea about whatever thing we have discussed, and if you actually think these classes are very good for you, I just want your suggestions and the questions, if any, or you can actually put a thumbs up so that I can continue the classes and help you with better lessons. Thank you.